Hello everybody and welcome to this quick tutorial, which then still turned out to be an hour. Sorry, I really tried, but this is a really good one. So the main objective of this exercise is to build this charging stand. But before we built a charging stand, we needed to build a basic iPhone. And I'll show you how to do this by getting actually some reference photos from the Apple website. Everything is also rotated. It started built vertically. Then we will go ahead and via some measurements, build this induction charging pod, snap it onto the iPhone there, and then we just rotate the iPhone into the position. Yeah, and then we will build this stand. Very cool, no? We will then add some materials, and I will give you a brief introduction into how we can create screenshots actually from this view, how we also then can create screenshots from the rendered view, and then even use the built-in render engine and the cloud to create somewhat more photorealistic images. Okay, so let's do it. That's going to be cool, I promise. So the first thing you want to do is go to any web browser and then Google for Apple Accessory Design Guidelines. And that is a PDF Apple gives out to everybody who would like to create accessories, smartphone case, iWatch case, and whatever. You have all types of information in there, USB adapters, protocols, and, well, also dimensional drawings for all the devices. That's exactly what I want. So here is the iPhone 12 Pro Max. Let's use this one. As you can see, we have different views, details, front, back, camera restrictions. For example, if you develop a case that goes over the phone, heat suspension, and whatnot. All we are curious about is this front view and the side view maybe for the thickness. We're not going to rebuild the phone. So all we need is just simply a nice front image. So we could just quickly redraw something that looks like the iPhone. Let's say like this there. So here I'm taking a screenshot of this, try to make the image nicely proportional, and also I'm doing the screenshot from the web browser. The more you can zoom in, the better. So for example, on Mac or PC, you can also download the PDF onto your desktop and then use a different program. In Fusion now, we can first turn off the timeline. There we are. Then we'll make sure that the unit system is millimeter. Very good. We can go to the front view. And then we insert a canvas. I will go to where I have the screenshot. There we are on this plane. Rotate and scale up. And there, that's the top. Very good. Click OK, right click, edit calibration, there to there. This is 78.07. And I might have to flip it. Nope. This way. Very good. And then eyeball it so that it looks kind of maybe centered. Very good. Okay, then we can make a sketch from the front view. And we're going to rebuild this only in a very simplistic way, since the iPhone is going to be just a placeholder. The focus will be the holder for the magnetic battery recharger. So here's a rectangle. D dimension for the top, 78.07. Now I need to understand how tall is this. And when I go back to the PDF, I can see here product length 160.84 millimeters. So 160.84 millimeters. There we are. Good. We can actually see that the image is a little bit too low, so we can right click edit the image and move this up. Good. So the reason why I brought in the image is actually I would like to capture these corners as well as possible. Okay. So now I can go ahead and say, for example, extrude this back, but how deep? So I can go back to that PDF. Here we are. And then there I see product thickness 7 millimeters 39. So then for the extrusion, I type in 7 millimeters 39 and enter. That's it. Okay, very good. Let's go to the fillet command. Click on this edge and then we will round this edge. And you see this is actually a G1 fillet. So if I do this fillet, you will notice I'm not really 100% getting this detail because we have to go to a G2 fillet. This is a much nicer design. And there, this looks like nearly it. So 15 millimeters for our task is fine. Okay, so 15 millimeters is what we need. Good. So then I can select the other two edges there, G2 and 15 millimeters. And enter. Very good. And maybe turn off the sketch. Again, and this is an extremely simplistic design. Really brutal. For presentation purpose, if let's say at one point we would like to put on an interface or something, what we could do in addition is maybe show where's the actual display and where are borders and such. You see there are actually some edges. There's a frame and then there's another thing and then here there's a display. So the initial sketch we can hide and maybe I should actually bring this image now to a different plane maybe. Let's see, how do we do this? Maybe I bring this backwards. Let's see, can I see it through? Yeah, I can see it through. That's good. So what I will do is create sketch now on the front face of the iPhone. And then first we will do an offset of this whole outer frame. Look at this, it's just 1 millimeter. That's probably for the frame. Okay, good. Then let's do an offset one more time. How much is this? Let's say 3.5 millimeters. Okay, and then we have this thing here. Now this is actually pretty easy to do. So let's work with a rectangle here from the center. I just draw this rectangle. I try to line this up. I eyeball this here. In this case, it's fine. Okay. And then this gets trimmed, 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 trimmed. Very good. Then delete, 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 and delete. Delete. And then we have here these roundings. So we have a fillet tool here. So you and you, we can fillet. Looks like 3.5. Okay, keep that in mind, these numbers. And then here we do a fillet to 1. Let's say 1, so 3.5 and 1. The fillets inside the sketch are G1 only, so tangent. So good for mechanical cylindrical shapes, not really for industrial design styling. So for what we're doing here, however, okay, this is fine. Here is also going to be maybe a small slot. So on this grid, I try to eyeball this again a little bit and check out how very quickly I'm just building this. So from the midpoint, I'm drawing 2 circles up and then trim, trim, and trim, trim, trim. So I'm just cutting away all these other elements. Okay, escape, and when I drag the selection, I should be able to drag this down where it should be. Make sure it still snaps to the grid. Now, and in case things here, as you can see, start moving, then tangency constraints for the arc and the line. So this is perfect. And then here's my midpoint, which I should be able to move around. or not. Welcome to the sketch engine. Sometimes it works beautifully, sometimes it does not. So let's help this engine first. We give this a dimension, so 0.5 millimeter. Okay, then what is actually right click? The tangency dimension. 8 millimeters or 7.5. Okay, now I would like this thing here to be centered. So look, I'm doing this trick with a line. This line on the grid I lock, then this line I make construction, and then this line I make horizontal, and it pushes it down. And now this will be easy to move this up and down. There are also more dimensions for this opening. I just kept this a little bit more simplified. And there we are. Cool. So from this side also we see these buttons. Now if one wants to do, you can go to the additional views. So like here, and then you could take a screenshot from this, put the screenshot to the side, you have the dimensions, and then you can start tracing in roughly these interface elements. Where, for example, here, this other view, there's other view from the other side. So all the dimensions are there. For those who are curious, why, for example, this corner curve here looks kind of crazy with all these points. This basically gives you where are points on the rounded edge the curve has to flow through. Because I don't tell you this is a G2 with this amount of value or etc. So to describe actually the flow of a curve, so not a circle, because that's a radius, the flow of a curve with these values. That's pretty much easy stuff. Adding actually all these other elements can make the model more realistic, but that can also then make the model more a distraction when, like in our case, all we want to do is just focus on the stand that's going to hold the induction charger. So back in Fusion, I click Finish Sketch. So this is all good. I can turn this off. No, it doesn't look too bad. And what I did now with the sketch is I can slice, for example, the face. So split face. So this face I would like to split by this spline there. I'm going to now turn off the sketch. There you can see there's a small rim. That rim, for example, we could then give a different material. One more time, split face. So this one split by this interior sketch there. There we are. Well, you see. Oh, it looks like an iPhone. A very highly sophisticated rectangle with nicely G2 corners. So the demo part for the iPhone is actually done. What we can do now, I think, is we can select all the stuff and then let's see, or no, we can actually create a new component. There we are. This component, right click and rename, we call iPhone. There we are. And then let's see, can we actually drag all these sketches in there? So the sketches, you see, I was able to drag into that component. What about the canvas? The canvas goes too, and then the body. Cool. So you see, actually, we created a component, and then all these additional elements we put in there, and just also the geometry. And with the component, we now have, kind of like one building block, which we can save, share with other files. I use here also a component because essentially the phone is a logical part in an assembly. So I want this to have its own hierarchy, meaning inside the component container, I have the geometry, the canvas, and for example, the sketches. At this point now, it's time to work on the actual induction charger. That's a very simple device. So we can create a sketch. There we are. I do this in the front view. Here is a circle and the radius is 60 millimeters. Very complicated. Okay. And then we can click Finish Sketch. We're going to extrude this. And I'm just going to simply, with a caliper right now, measure the thickness. Oh, interesting. Also 7 millimeters. I guess I took some clues from somebody. Cool. So the disc, or not necessarily the disc, it has actually an aluminum shell. So I'm going to show you now how we can build the shell. It's actually simply a 1 millimeter thickness there. So now we have this and this, all a 1 millimeter aluminum shell. And inside this cavity, we're going to put in now the geometry for what should represent where the induction charge is. Easy thing is, from now this new resulting interior cylinder, I'm going to extrude something new out as a new body. And for the distance, I say to object on this face. There. So now you see it actually extruded it right to this edge. But I want this a tiny bit longer. So now I go with the face selected to move and move this maybe by 1/10 of a millimeter. So there's just a tiny step over. Cool. Okay. Very nice. Okay. So now we have actually the puck and the shell. We might want also at this point to think about the cable. So the cable is, let's say, on the bottom. How do I position the cable perfectly centered there? So we can create a construction plane. For example, is there a midpoint? So when we look through here, like a midplane between two faces. Ah, interesting. So between this face and this face. Oh, look at that. It found actually the midpoint. Perfect. That's just what I need. So on this plane, we create a sketch. And then I would like to know where this thing is. So intersect this circle with the sketch. There you see now there's the intersection. I can hide all this. And then using my amazing caliper, which I bought from Aldi. Very good. Does the same job as more expensive pieces. So this is kind of like a 4.5 millimeter by, looks like 10 millimeter. So doing a rectangular drawing. So from here, we said this should be 10 millimeters. Then the thickness was 4.5. Now 4.5 divided by 2 for the mathematically lazy people and those who have to do math while doing a recording. There we can simply calculate this, and then I draw a straight line up. But you see I'm going into the sketch and go back. So the main reason for that simply is I can now do a nice cylindrical rotation there. Long, there we are. So that's a little bit more correct. Yeah, there's the piece. Ta-da, easy peasy. If we want to be correct, from this metal shell, we could cut this also out, keep the tool, because now the cable actually is fed through there during the manufacturing process. So I would say, yeah, new component. And then charger disk. There we are. And then all this goes in there. And drag it in. Very nice. Oh yeah, here also the construction plane. So one advantage of moving this all into a compartment is later when I move this compartment, not the body, but the compartment, and I would like to move it around, you see everything moves with it. So it's kind of like you select everything and just drag it around. It's like a storage box if you want to see it this way. Cool. So now we have actually the charger and we have the phone. right at the same position. So the phone, for example, I will move to somewhere else right now. There's also inside the PDF an information about where, for example, this thing has to land. So when I go back here to this PDF now, so this is the front, there's the back, and product center. So this here, for example, it talks about the MagSafe. Now, so this is for the where the induction would be. So if the device is at the bottom, it's not really going to work over the cameras. Well, it doesn't really work over the cameras. Plus, from the side, we can see the cameras are in the way. So it has to be positioned somewhere here. Plus, this is all magnetic, so it will snap into the correct position. This back view, for example, the distance here will be very useful to understand, because at one point we need to know where is there actually also the limit for where this stuff is. So what I actually might do at this point, now before we continue, is I'm going to create myself a small screenshot here from the site. So like this. There we are. And then this screenshot I'm going to bring into Fusion. In Fusion now, I would like to bring this to the iPhone. I will actually undo my movement so the iPhone is back centered. I will activate this component. Very good. And now here from the side, I'm going to insert another canvas. So this one here. Yeah, canvases are hidden. There we are. Then we are going to rotate it. Very good. Then I need to calibrate that canvas. So there I have a point from there to there, and that should be 103.09 millimeters. Yeah, that looks good. And then I simply try to move this so it fits. Oh, look at that. It is actually a good match. Very good. So when I rename this maybe side, and this I rename front, I can at least from the side now understand now where is the center. Just as a little tip. And you see, by having actually had this component activated, when I edited it, added it right to the canvas folder inside this component. Pretty smart. Okay, very good. So let's maybe can turn this off, turn this back on. And what I now would like to do is, let's say the phone should be maybe rotated at a certain point. How do I like this to see, and how far off the ground, for example, should the phone be? So I will select this component and go to move. Now the component, move this to somewhere else. You see how everything again moves with it, and then I can rotate it. Obviously, this type of rotation, if it's on a table, only makes sense if the phone is right below me. This vertical makes sense if it's eye level. If it's on the table a little bit further away, let's say minus 25 degrees, 20 degrees, that sounds good. Okay, good. Here I have a distance. I will actually, no, I do not want to make a new sketch on this component. So I go back to the root, and then here I draw a sketch and simply draw something up. So 25 millimeters, which means, yeah, now here this is 5 centimeters. How far do I want this off the ground? 2 centimeters. Again, if you see these numbers, I don't mean much. just get a ruler and maybe hold this off the ground as much. And that's kind of like what I'm doing here right now. So I'm holding this at 2 centimeters, at 5 centimeters, 4 centimeters, for example, looks good. So 40 millimeters. There we are. Okay. Then going back here to the iPhone, I can move this component and say, oh yeah, plus minus, just maybe be there. Okie dokie. That's fine. Can we actually do an align? I think this component, we can maybe say, oh yeah, look from this midpoint to there. Suck. See, I perfectly positioned this lower corner even onto this line. How fancy. So how do we bring this to there? I think we can use the align command for that. So align and say from, yeah, no, we have to be careful now. So from which one? This component face. Keep in mind now we have the flat and the bigger one to there. Yeah, did it. Very good. Very nice. This actually looks good. And now the task actually to draw the, how can I say that? The holder for the iPhone and for the component is basically pretty simple. Now we can just go into edit sketch. This is all aluminum. This is aluminum. Now the question is, do we make this all out of aluminum? Okay, now we can do this. We just do a very simple stand. Since this whole exercise is showing you how to work with components and exterior pieces. So I will go ahead and say, intersect, please, this component, so the phone, into my new sketch. You see also I'm on the root. This is important. Click OK. There we have this. So this means, okay, so this is basically the line where the iPhone is going to sit on. Here maybe I have a ground line. There we are. Very nice. And I'm just trying to think out now how I'm going to build this piece. Do I do this right here with a material thickness and round this out? But I will actually go rather with a surface, and then I add thickness, and then I continue doing all that stuff. So that means this line here, I will continue. Oh, look, this is parallel. Very good. To there. Okay, thank you. And then this go to there. Thank you. This is horizontal. This point horizontal to the origin. Very nice. Center of gravity. Yeah, maybe here. This is fine. We would need to make a physical prototype and see where's the center, how far is this stable. Plus this will be rounded too. Now we need to keep this in mind. This is, let's say 90 millimeters. Very good. Thank you. Then we can do the following. I am going to extrude actually this whole thing. So all 3 lines I would like to extrude. So 40. So we'll be as wide. And then let's here say symmetry. Does it need to be as wide? Can this be a little bit smaller? So for example, it sits on it. Do we make this a little bit wider so it like, no, you see the phone is smaller, or do we make this match? It's up to us to decide. I will specify this with 38. So it's slightly behind. Very good. Very nice. Or I could also use exactly the same dimension for the iPhone. So here's the sketch. and show dimension. No, 78. I can copy this out. Very good. This maybe I delete and just do another extrusion. Symmetry to the maximum width of 78.07. Cool. Okay, now we have this crazy thing here. Check this out. This is a very simple trick. Yeah, we select this now and then we can round this till there. And then we give this a nice G2 fillet. And I would like to change the flow a little bit. You see how with this thing I'm pulling this a little bit. This is actually the tangency weight. 0.5, 6, 7. Yeah, this looks good. Okay. Then this whole thing we're going now to give a thickness. There, let's give this a thickness of 2 millimeters, 5 millimeters, and the opposite direction there. Okay, all looks good. Also here the interior radius. Keep in mind now the charging disk was actually 7. So what about 8 millimeters? How does this look? You see how this is getting a little bit tight now. What about with 9? Yeah, let's go with 8. Okay, good. This is good. Okay. Yeah, fine. I'm not really super happy about how this deforms. This needs to be thicker. This does not need to be thicker. So we identified the problem. Let me show you now how we fix this problem. I'm going to do an extrusion of these two lines, not the line in between. Same process again. Symmetry. And then 78 something. There we are. Thank you. And this edge, I would like to be a little bit shorter. Okay, even at the midpoint. I see here's the line, which is kind of like at the X line. So that means this line I can trim by using this plane here. Clong, cut this off. Thank you. So go to solid. Then this we extrude into 8 millimeters. Or let's say 9. Let's go 1 extra, 1 millimeter. Very good. And then we are going to extrude this into maybe 3 millimeters. Make this nice and thin. Very good. This face I would like to rotate a little bit. I might have to move this to there. No, wait. Click, so repositioned the rotation center, and then I can move this one up. Thank you. And then move this one down. Since I rotated the piece a little bit, so one more time. So I select the face, then I go to here, then I select set the pivot point right there. So these 2 millimeters remain the same. Done. And then I can change this a little bit, maybe 3 degree, 2 degree. Okay, 2 is fine. You see it's getting a small wedge. And now here comes the nice trick, loft. And we say U to U. Please Fusion do it. G2, G2. Ha, 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 ha. Look at this. And then I can make these individual transitions. And look at that. No? This now from the side is much better. Also much less material. This is cheaper. And actually it looks more elegant. So we can join it. There we are. Cool. So U was a nice study. Bang, you're gone. And then these surfaces we can keep or we just delete. No. Dissolve everything. All good. The iPhone. We need to see the canvas side, because you remember the camera part. So this is way too high. Let's bring this down. How far? Minus 48. Very good. So definitely enough to make sure that the camera is free. This is actually a little bit tight. We could calculate the volume, or we eyeball this right now and we add maybe 3 millimeters back up there. Beautiful. Yeah, it doesn't look too bad. Okay. So iPhone is done. No. Yeah, what do we do with the rest? So here is actually the puck. So I can go and say, from you, I would like the outer disk and the inner disk maybe removed. Keep the tool. And this may be a little bit difficult to see. So let me undo this step. And for the charger here, I turn all this off one more time. Then from you, please take off the outer rim. And one more time from you, the inner disk there. And then when we turn this off, there we are. Okay, you see there is a little bit of an issue, no? See, there's a little bit of a flange. Yeah, why is that? Well, that is because the puck didn't completely cover everything. Whoa, what's going on here? So this face, I would like to extrude. And then you see with extruding this, we make this cleaner, clean this up. And then this should be 30, 60 millimeter diameter. We can make this a tick wider. We say 30.1. So kind of like there's a little bit of a tolerance for that thing to sit in. Beautiful. Okay. This is actually really taking good shape. Now we need to figure out how do we do the cable. How do we feed the cable through it? So kind of like there, and then here coming out. So on this face, let's go ahead. Let's make a drawing. This is a rectangular view. We know 4.5 millimeter was for the cable slot. So here's my rectangle. There we are. I will make this simply 5 millimeters. So D 5 millimeters. This has to be centered on the grid. This thing, for example, I will make we set 10 millimeters. I go with 11. 11, so it can grow a little bit into the piece. So this is now 11. This would be 10, meaning this edge here should right now line up really with this piece. Oh, look at that. No, it really does. Very good. So this can go, but maybe let's give this a little bit more spiel. Kind of funny how German words make it into English. Zeitgeist and all these words there, like this. Very good. So we have 2 millimeter of extra space, so one up, and then I'm going to extrude this thing. Yeah, how far do we extrude this one in? I don't know yet. I go a little bit further, kind of like till there. All these parts I'm going to dissolve. Very good. Then I can take a look at the charger again. Yeah, here maybe dissolve all this. These sketches I hide. Maybe I want to go into a section view from the side. I think this is what I need now. There, very good. Wow, I'm actually really close. So maybe we can even keep the depth. What line do I have here? 4.6 millimeters. What thickness do I have? 2.8. Okay, so this, I go press pull and then re-anchor from the back face. That should maybe be, let's make it clean, 2.5 millimeters. Okay, very good. Now the cable has a little bit of wiggle room. All super good. But now we have the cable itself running through it. So I'm going to hide all this or collapse it more or less. Very good. And I'm creating one last sketch, and then I'm simply drawing, no, not with the fit point, but with the control spline point. Click, 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 and then maybe it should go in, then it goes to there, there, and then it leaves the whole design. Okay. So now, so how do we do this? This is going to be interesting because we need to feed that thing somewhat through it. The problem is the cable, also the USB charger, has a thickness now. So if I go ahead and try to measure it now, so this is maybe, let's say 6 millimeters to 10 millimeters. Yeah, how do we do this? This is actually a tricky task now. Now do we work with two shells, the left and the right of aluminum, as kind of silly. When I hide actually the sketches and take a look at this and this, how big is this? So 5 millimeters. What did we say? How thick is that thing? 5.5. There's a design opportunity. And then the other thing is maybe 10. So look at this. This is actually 11. This is 5. So what we could do is we do the following. When this is nearly 5 millimeters by 10 millimeters, let's do this. We just cut a hole. Suck. So through this hole, later we can actually feed the cable through this opening. This is a little bit crude. So let's go and round this hole. I think this should be 2.5. Yeah, now we have a nice half round. And we can also do the same here. There we are. 2.5. Very good. So from here now we can put through a USB-C holder easily. Not holder, the adapter. And then when we take a look at the charger, yeah, it nearly fits. Okay, so this we might actually need to move down a little bit. Can we do this? Unfortunately, Fusion does not in this case here. Oh wait, hold on. No, I shouldn't have complained. Let's do this one more time. So here, reposition this to there, click OK, and now I can move this down. Good. -1 and enter. Yeah, okay. So this is a little bit bigger, but this is fine. And it also looks nice and clean and sophisticated. For the last step then, now we can go ahead, either on the back we can do this, or on the front. I will simply use the back. There we are. And we will create a small sketch, rectangular. We can see kind of like where the cable comes out. No? So there's my rectangle, 2 millimeters. How wide is such a cable? Also a good task to measure. Yeah, looks like 3 millimeters. Okay, so Then we will give this with D a dimension of 3 millimeters. Whoa. And position this centered. There we are. Maybe this edge and M I move up. And then this edge I move down. Okay. And then simply what I will do is I will select this profile and cut a groove in. I can see actually also where the cable is, so I can bring this to there till this plus minus lines up. I can go maybe to the side view, turn the section cut on. There, now I can see this best. So it looks like minus 7.5 millimeters. Okay. So now I drilled in this groove. And from there, now the cable can go out. Yeah, that actually can work. So you see how I used also sketching and 3D modeling problem solving this design I show you here right now. I'm simply making up while on the fly, while I'm exposed to problems. I'm trying to come up with quick solutions while doing the recording, which is also why this is maybe a little bit longer, and it shows also some of the struggles, which I think is good to see. Here, this radius, what did we use actually for this radius? 15 millimeters. No, okay, good. So here, these we do 15 millimeters and G2. Thank you. Very good. Then side view. This is actually charger, fillet, dissolve. Dissolve. There we are. We are going to create a new component. This is stand. There we are. And then we have to see what all goes in there. So definitely this piece goes into stand. And then the sketch. So stand. This is the cable, stand. So the cable one, that actually has to go into the charging disk. So there we are, very good. Yeah, how do we do this perfectly? You see that I deleted the sketch, no? That was on purpose. No, I should not have deleted it. But what I wanted to do first is I want this thing to be perfect. So I will create a line through this cylinder. What? Oh. Okay, good. If I now click on this cylinder, there you see this. There's this axis line. Thank you. Height. Actually, the show height, this one. And there is my thing. And I just need to see this disk. Very good. So on this sketch now, I'm going to intersect this. Nice. So there we see there's actually the axis. There's my midpoint, which means, hey, you on this midpoint, thank you. I can press P to project this in. Or since we use a CV curve, I think this line to here can be perpendicular. Yeah, it does. So very good. And then you and you, we make parallel. So this cable now comes out nicely tangent. Then let's show our stand, side view, very good. There we can see how, now does this work? Yeah, maybe we have to mill actually the stand out a little bit more. So at this point, now I click, drag to there. Very good. The way how I drew these curves is actually pretty fine. Very nice. Very good. Okay, okay, okay. And then on, I'm going to go to the stand. Sometimes these sketches and planes are really becoming obtrusive. So there we are. And then this, I can maybe push down another -5 millimeters. Okay, yeah, maybe at one point the cable has to change a little bit. It's fine. Okay, and then back to the charger. So this thing is now a cable. There's my pipe. We set 2 millimeters distance. Huh? Hold on 1 second. What is this? One more time. I clicked on something incorrect. Section size 2 millimeters. Ah, there. Do not join. Thank you. As a new body. Very good. Then let's go to here. Look at that. There's actually everything. No, here you can see that. And to bring this now to an end, we can design something that, for example, holds the cable so it doesn't go left and or right. Could do a very simple plastic piece. I'm going to skip this, or maybe the cable here. Now from the, I go to the top view. This point in the sketch I would like to change. So edit and then 3D sketch. And I think I can move this out now a little bit. Yeah, bring this maybe to here or so, and then here, this point. Oh, why? Draw this again. You see how this thing is kind of like cricket. So I'm going to undo my steps one more time. And I'm trying to find a good orientation. This orientation is good. So now when I move this, I have to do this one more time. I can go onto this line. Thank you. There. Very good. So this cable, oops, we can select this cable and delete. And then we just redo the pipe. 2 millimeters, new body. Okay, very good. And yeah, we need to bring in the USB charging part. So I went to GrabCAD, logged in, looked for a USB-C cable that is the shape I want, this one with the rounded parts. Then I downloaded it, I unzipped the file. And then in Fusion, we go to File and Open. You navigate to your Downloads folder. There is the step file. Yep, there we are. Then we can simply save this. So save, complete. Yeah, that's good. That's just a demo piece. There we are. I'm going to save this. Charging stand. There we are. Very good. And then here's the cable. Right click, insert into current design. We're going to import it. Yeah, okay. And then right click and say break link. So we can go into this component. This we want, we don't, we keep. Oh, good. So all the other stuff here we keep. Very nice. And look at that. There's a nice round cap. There's a nice round cap. Beautiful. So we go to align and say align the end cap to the end cap. Okay, why didn't this work? Ah, my fault. So I need to select, I think, this whole component probably, not just a subcomponent. So this whole component, yeah, you see everything is selected. That was my fault. Clonk. Yeah. Why does this happen? No. Okay, hold on. That is interesting. Because normally it should work. So one more time. Align. Yeah, the whole component. Maybe if I select all components? No. So this component to this component. Yeah, I love it when this happens in a demo. Wah, wah. Okay. You know what? You and you and you and you all join together into one piece. Clock. So go and go. Yeah, we can keep this, or you to you join. And it seems not to work. Okay, now let's throw this out. Basta. This is not a so important piece. So you to you. There. Problem solved. Ta-da! Very good. Okay. So we actually created our charging stand. Then we can go ahead and turn off everything we don't really need. So this I put to the charging cable there. Yeah, because this is actually part of that whole system. There's the stand. Here's the phone. The phone, turn all these sketches off. What is this? Oh, that's the cable that goes into charging disk. There. Very good. Last tiny detail here, these edges 1 millimeter. We can round them 0.5 if we want to be super duper G2. Very good. Okay. Also, the phone has actually some slightly rounded corners. 0.1 G2. So we just do this very slightly. Okay. Very nice. So the model at this point now is kind of done. Very good. Then let's press A to add some materials. We can quickly go ahead and say where is the metal. So here's aluminum, and then I'm looking for anodized rough gray. That's actually good. So I push this on it. The phone is an interesting topic. Where do we have maybe a basic material? So the phone I will give something different. The phone I will also hide, and then the stand is gone. This is aluminum, okay, for the case. Then I will go to, where's plastic? Maybe opaque. Opaque. There we are. Glossy white. Okay, glossy white for all those here. Clonk. And then matte plastic white for the disc now that's inside. This all can be glossy. This is not glossy. So you are done. The stand is done. What about the iPhone? Yeah, so this one we just make a it's up to you. We can make this kind of like a gray, so it will look like nothing. Or We yeah, keep this maybe this way, and then now I go via faces and I select. Actually, this will be easy if I do it this way. I will, where there's aluminum there, and then this I actually will make matte white. And maybe here, this is a thin one, maybe a matte gray. Not black, because black would be a too strong contrast. We would see this. I just try to work with very simplistic colors to give this a little bit of a logic. Okay, so this is actually very good. So, why did I create materials? Easy. Let's go to the render module. So it has a render module built in. It's not super strong, but it's good to create basic snapshots. So we have here scene setup. We can, you see there's a backdrop. We can adjust the brightness, for example, position. We can change the position of the shadow or from where the light comes, like this. Very good. We have environment color, or actually show me the scene. You see there's an environment which we are, when we click on this, we are rotating. That creates actually the highlights. We have depth of field. For those who would like to play around with this, you can click on something. There are also other HDRs, so environments to illuminate the space. Very good. So the light comes from the left side. That is kind of okay. And then we can do an in-canvas rendering. Try to see how this works. There we see. That looks like anodized aluminum, white plastic, glossy. This is maybe like matte plastic. We can turn also the iPhone off. Then we only see the stand. Now I don't really like the grayish background. So let's go back to the setup and say, just go with a solid color. Oh, but maybe just make this nice, clean white. Pure white, because then it's easy to be put into an environment, kind of like on a presentation board, for example. I can also have a ground plane or turn it off, no? I can show some basic reflections. That's kind of cheesy. That's the reason why I don't show this. What about we give this a color? Okay, now let's see if we can play with this. What about we make this really dark? So it's actually quite interesting how you can play there with it. When you do it in black, then actually the reflections can make sense. Now this actually doesn't look too bad. Something is happening on the ground, but I really primarily look onto the phone. So let's keep this. This in-canvas rendering, you see here, it's progresses, and then excellent, final, and infinite. This is kind of like the type of quality. You see this gets grainier and grainier. And then once it's done, you can say capture the image, the current view. So what you see here then is being captured, including transparent background. Let's say save this to the computer. I will put this onto the desktop. There we are, save. And we can also render something in the cloud. So here's my layout. That's kind of like what we see here. Cloud, final quality, 2 credits. Is this rendering? You have a certain amount of credits. Once a job is done, you get the credits back. Render, then it's uploading, and you see here now there is the gallery. So it's working right now, and once it's done, then we can take a look at that image. And while this one is rendering, now you can also go to, for example, the front view, and we can do the rendering here, or we can also go to the design view, let's say like this. And then every time when you click on these views, you see how it rotates it, but it doesn't zoom in and zoom out. So I'm going to show you how we can create also orthographic views. We have here also orthographic views and perspective. Now, so this is now truly perspective or orthographic. And when you would like to create a screenshot of this, let's say I would like this view to be put into a presentation. With this done, then I can go and say capture screenshot, current view, transparent background, enable anti-aliasing. Yep. Okay. And let's say I call this screenshot. There we are. Very good. And then on the desktop, there we are. You see, there's a screenshot and it is perfectly transparent in the background. And then when you zoom in, you can see here the edges are not as jagged, so they are anti-aliased. So this is actually the easiest way how we can create orthographic views from Fusion. The last thing maybe to say is image size. If you want to print something, you want bigger images. So we go back to here. We can go also custom. Now we can say instead of 9,000, well, can we actually do multiply by 2? No, we can't. So let's say 4,000 pixels. Now this is actually much bigger. So I'm going to do this and call this one out screenshot large and save as PNG, not JPEG, obviously. And if we then take a look at these images on the desktop, at first they might look not really much different, but if I go forward and backwards, you notice that the old version has thick lines, the new version has thin lines. But the big difference is this is kind of like 2000 and this has 4000. Really interesting is when we go and take a look at each image. There we are, next to each other, and I will go to view 100%, so actual size. And there you see, this is the one with 4000 pixels, how much more pixels. So I can actually zoom in more, or I can also print it on a bigger page. No? So for if you have like a letter or a tabloid or a big poster, this way then you can create the screenshot with the amount of pixels per image you really need. And while we created screenshots inside the design environment, the same we can also do inside the render module. Now you know that we can turn on the rendering process and it will take some time to create a more photorealistic rendering and then we can save it. But if we are in this view and for example turn on all these effects down here, including shadows, look at the shadow there. It's not perfect shadow, but it can work. And we can rotate around. Yeah, we can do exactly the same here now. Position everything nicely and then we go and say capture, put in our information, and then it creates a screenshot of this environment with the black background, the nice reflection on the ground. Let me go back to the gallery. You see this is actually still rendering. This is 6 minutes ago, so I will stop the video actually at this point. But once this is done, you will have a screenshot of this. You can then double click and it will actually open the rendering gallery. You see it's still working. And then here where my mouse is, this is where you have then the ability to download the finished image from the cloud onto your computer. Yeah, and that basically is everything what I wanted to show you in this exercise. I hope you liked it.